So we are on the last video, video number 3 for Unit 7, Day 1. And in this video, we are going to look at two different examples of sketching graphs given a bunch of information about the functions. So our first example, we have a graph of a function f at x where we're told all of this information. So it says f prime at x is less than 0 when x is less than -1. And if we kind of think about what that means that the derivative is negative when x is less than -1. We know that a negative derivative means the function is decreasing. F prime at x is greater than 0 when x is between -1 and 2. So greater than 0 derivative, positive derivative means f at x is increasing. And then f prime at x is less than 0 after x equals 2. So again, we've gone to a negative derivative value and decreasing. I'm just going to kind of make some notes here about what that means. So looking here, I know if I lay out on a number line, I'm given information about the points where x equals -1 and x equals 2. And I'm just going to kind of summarize with f prime at x and f at x and what that means between them. So we are told that f prime is negative or less than 0. We know that what that means about the graph of the actual function is that it's decreasing. F prime at x is positive between -1 and 2, so we know that we have an increasing function. And then after 2, f prime is negative again, which means we have a decreasing function. Okay. The next piece of information here, if we were to look at this line here, f prime at -1 equals 0, f prime at 2 equals 0. So this means x equals -1 and x equals 2 are critical numbers on my function. So remember where the derivative is, wherever you have the derivative equaling to 0 or does not exist, those are critical numbers. So those are critical numbers. And the last piece of information here is f at -1 equals 3 and f at 2 equals 7. That'll let us get some actual values to be able to graph this function. So I'm going to just write these out as coordinate pairs. So when x equals -1, y equals 3. When x equals 2, y equals 7. So these are points on my function. I'm going to put all of this together to do a quick sketch. It's not going to be super accurate here, but it should be accurate at least to the points that we're given. So we have been given 2 points, and that's the first information that I'm going to put on there. I know that the point -1, 3 is a point on my function, and I know that the point 2, 7 is a point on my function. That those points will be on the graph. And now from here, I know that the function is decreasing until x equals -1, then increasing, then decreasing again. So using these 2 points kind of as a guide, I know the function's decreasing to this point, increasing, and then decreasing. And I know that the slope of the tangent of the function at those 2 points that I've labeled is 0. So here we can kind of fill in. This function is decreasing down to this point and comes to a slope of a tangent of 0. And then it's increasing, coming in again to a slope of a tangent of 0, and then decreasing after that point. So I don't know much about the other pieces of this function. I don't know the intercepts. I don't know really too much about the scale of this or how steeply this graph is shaped, but I do have a pretty good sketch just from finding the critical numbers and the intervals of increase and decrease. So I'm going to do the same thing to with the next question. Again, I'm given some information about a function. This time it says that the derivative is positive when x is less than -3. So remember, a positive derivative means that the function is increasing. And then between -3 and 1, the derivative is negative, less than 0. And again, that's going to mean a decreasing function. And then a positive derivative after x equals 1, which means an increasing function. So I'm going to kind of do the same idea again here. With my rough work, just drawing out a number line. And I know that the important things, that's a really crooked number line. The important things here are -3 and 1. And I'm going to talk about the derivative and the function. So just kind of listing out what the derivative is doing and then what the function is doing. So we are told that f prime is positive when x is less than 3. So in this interval here, -3 all the way to -infinity, the derivative is positive. That means my function's increasing. So this is a really important relationship to get. If you know the sign of the derivative, you know the direction, increasing versus decreasing, of the actual function. Then here from -3 to 1, we've got a negative derivative and a decreasing function, and after x equals 1, a positive derivative, increasing function. So already you can kind of see, just from that little bit, you see quite a bit about the actual shape of the function. It goes up, then down, and then up, and it changes direction at the -3 and the 1. Okay. Again, this next piece of information here, the derivative equals 0 when x equals -3 and x equals 1. So we know that -3 and 1 are critical numbers. And the last piece of information, we're given 2 points that lie on the function. F at -3 is 4 and f at 1 is 2. So I can list out the coordinate pairs. That the point -3, 4 will be on the function, and the point 1, 2 will be on the function. So that's the information I know. I'm going to move to do a sketch based on this. Again, I'm not using graph paper, but you absolutely could. So the first thing I'm going to put is actual points that lie on the function. So here I'm going to graph the points -3, 4 and the point 1, 2. So I'm going to put -3, 4 and put an actual point. And then the point 1, 2 and put an actual point. Okay. Then this piece of information here with the increase and decrease, I know it's increasing, decreasing, increasing, and it's turning around at these points. Those are going to be turning points on the functions, those critical numbers, because I see the direction changing from my little table there. So it's increasing to this point, decreasing to this point, and increasing, and the slope of the tangents at those 2 points are 0. So I know it's increasing after there, it's increasing before there, and then it's decreasing between those points, and I want to level it off so that the slope of the tangent is clearly 0 at those 2 points. And that's it. So you should be able to put together information about values of the derivative, values of the function, and be able to get a reasonable picture of what your graph will look like based on that information.